In this short video, we're going to talk about Robbins' definition, and Robbins' definition of economics, that is, of course, and this problem of science and whether economics is a science or not. It's an extremely detailed subject, and we're not going to get into it to the same degree of detail as other people. There are many experts in the area and many learned articles published online and in the libraries, many books written on the subject. I want to just create a feeling for the type of debate there is and see what comes of it. For a start, let's look at Robbins' definition put forward by Lord Robbins back in the 1930s, I think it was. I've actually prepared one earlier, a bit like a cookery program. Saves writing it out. That is, that's the definition as put forward by Robbins. Economics is a science that studies human behavior as a relationship between ends and scarce means which have alternative uses. Economics is a science that studies human behavior as a relationship between ends and scarce means which have alternative uses. The definition is very famous, and it's absolutely full of key terms that we need to look at. And the one that we're going to focus on in this session is this idea of science. And it's complicated, but let's work our way through it and get a feel for the thing. For a start, before we truly get into it, we can note here immediately that science plus human behavior which is the next bit along, this bit down here. Science plus human behavior is equal to social science. So presumably what Robbins is saying here is that economics is a social science. That's fine. However, the problem now is what's meant by science. Well, the various definitions, but they seem to come down to something like it, that science is it's the systematic systematic study. You'll find other definitions of facts and or truths, if you like. To find general laws, find general relationships. So it's a systematic study of facts or truths to find something general. We try to generalize. That's the idea. The whole idea is to generalize so that we have a statement about the universe or about the world we live in or about something, and this statement encapsulates a lot of findings. By and large, when we do this, we use logic. And logic is a formal study. It's a bit like mathematics. It's a complicated study. It's got its own rules and its own areas of study, and really that's what they're using. And if you break one of the laws of logic, one of the laws of reasoning, then you commit what's known as a fallacy. But just to see how it works, we could have something like let's say something like all men hang on, this is a famous one. All men are mortal. Well, actually, it means all men are going to die, but mortality here, you have to have that attached to something which is organic, something which is going to die, in this case men, so we say beings. So all men are mortal beings. All men are going to die. Now that seems reasonable, and certainly it accords with our observations. Men die. So do women. In this case, because it's an old term, men is taken to mean male and female. There's nothing sexist about this. However, all men are so people die, and that's what the statement seems to be suggesting. Now, the problem is this word all. How do we know all men are mortal? Well, we use something called induction. Induction means we reason from observations, single observations. We build on it, we get more observations and so on, until eventually we say, look, we've seen so many of this, it must apply to all. We see one person, that one person died. We see another person, that person died. The history books are full of people who have died. Therefore, all men are mortal beings. We do it by counting it up. In other words, counting up, we make observations and count them up. So it's something called enumeration. Enumeration, and the enumeration is of observations. Observations. So we count up, and based on the counting up process, we come to a conclusion that all men are mortal beings. And this means we have a picture of where we sit in the scheme of things. We could have a Venn diagram for this one. The Venn diagram could simply be something like that, which is mortal beings. And in here we have the subset men. So men are a subset of mortal beings. And creatures die. So that seems fairly straightforward, really. We have a statement up here, which is, we call it a universal statement, a universal affirmative statement. It's universal because it applies to all, universal. It's affirmative. We're saying that all men are, it's affirmative, are mortal beings. And we can see a picture of it down here. Now, unfortunately, there are problems. There's always problems, but there are problems here. The problems with this one is problems with induction. Believe me, there are loads and loads of books published on this, many learned articles in journals and so on. So I'm not even skimming the surface, but it'll give an idea of the sort of debates that have been around. The first issue here we could pick up on is it's like a what if. What if problem. The what if could be, for example, what if we say we found some undiscovered person. Now, this undiscovered person has been around for the last 10,000 years. That would be a problem. Does that mean that all men are mortal beings? Well, we found one who's been around for 10,000 years, let's say. Been living out in the Amazon somewhere and just popped up. Well, we'd have to change this. We'd have to change it from all men to some men. But there again, we don't know, you see. Although we found him, he's 10,000 years old, he could still die. In which case we're back to all men are mortal beings. I suppose a better way of looking at that would be to go with are you mortal? Are you going to die? How do you know? You only know when you die. Before you die, there could be something strange about you that defies everything we know about medicine and the human condition, and perhaps you're going to live forever. We only know you're mortal when you're dead. So that's pretty strange. Let's get another piece of paper and continue this one. Let's go to the next problem. It's a problem about using generalizations into the future. So I said the first one here is the what if. Let's say we go to 2 here, and the 2 is call it generalizations. About the future. And that's not even stating it correctly. It's more to do with our understanding about the generalizations. Bertrand Russell, a great English philosopher, back in the 1960s, I think it was, he was interested in this problem, the problems of induction, and he gave an example. I don't know, just imagine a farm, and on the farm there is a farmer, and also on the farm there is a turkey. You can tell art was not my subject. There's the turkey. Doesn't look like a turkey, but it is. Now, the turkey has lived on the farm all its life, has never been off the farm, and every day the farmer comes across and feeds the turkey beautiful food. The turkey loves the farmer. Every day the turkey looks forward to seeing the farmer. All the turkey's experiences are that the farmer is a nice guy, a nice person. The turkey could not have predicted that Christmas was coming. And one day the turkey got a big surprise. So maybe what we believe, based on all of our experiences, might turn out to be not the proper interpretation of the true facts. Maybe we're all deceiving ourselves. Maybe we're all being a bit like the turkey. So maybe we make assumptions about the world from our perspectives, but our assumptions about the world and about the data and our interpretation of the data are themselves wrong, and perhaps we're believing things that are not quite right. Now, that may sound a bit strange, but maybe we are. Maybe we have got a problem here. Let's move to a different, back to the earlier one here. All men are mortal beings again. So we're back to all men are mortal beings. Now let's have a look at this, and let's just drop these out of the way for a second and pop this one down. There you go. I'm hiding something here, but all men are mortal beings. Socrates is a man. Therefore, Socrates is a mortal being. That's how it works. This is known as a syllogism in logic. S-Y-L-L-O-G-I-S-M. A syllogism. logic deals with syllogistic reasoning, which means to argue validly. It's not about the truth of this thing, it's just about arguing validly from what's known as a major premise with a minor premise to a conclusion. So we get to the conclusion by validly arguing with the major premise and the minor premise down to the conclusion. Now that looks pretty good, because that's what's called one mood of the syllogism. If you do logic, there are many moods to the syllogism, and it becomes a very complicated study. We're dealing with a very straightforward example here, all men are mortal beings, which is one of the easier moods of, or types. Mood is the same as a type of syllogism. Now let's apply this to a bit of economic thinking to see how it works. And that's the bit I was hiding, because I've written it out earlier for you. Just get it down so you can read it. Okay, here we've got every time the price of petrol rises, every time the price of petrol increases, less petrol is sold. So every time the price of petrol increases, less petrol is sold. The price of petrol has just increased, and therefore less petrol will be sold. Compare it. It's almost identical. All men are mortal beings. Every time, all. Every time, all. The price of petrol increases. All men. Less petrol is sold. Mortal beings. Then we go on. The price of petrol has just increased. Therefore, less petrol is sold. Now, this is what we call a testable hypothesis. We can test this one to see if it works. So it's a testable hypothesis. We can test this. We can collect the data and do some analysis of the data. We would also say that that's an empirical test. Empirical comes from physics and from the natural sciences. When you do something by experiment, in a way we're experimenting here with the data. So we collect some data. The price of petrol has just increased. We collect the data on the increase. We collect data on the petrol sales at various prices over the years, and we adjust them for inflation, and we do all sorts of complicated economics manipulations of the data to try and get a true picture, and then we do the test using some statistical technique. And that's called an empirical test. So we can test the data. Now, still doesn't answer the question. Is economics a science? Well, let's write it down. Is economics a science? Is economics a science? Well, big question. Lots and lots of papers again, lots and lots of books, lots of people involved in it. And you can check out a lot of this online. Many of the papers are actually published online. For the moment, we can observe, based on what we've been talking about, some issues. For example, the enumeration one. The counting up one. If we count up lots and lots, does that mean all? Um, if I said, as far as I know, all men are mortal beings, but I don't know. I don't know everybody. I haven't been to every part of the world. I haven't spoken to everybody. So I'm inducing this. I'm inducing it from my observations. After I've made several observations, I induce it. And that's a problem. Maybe in some areas with economics, we go from very limited observations to generalizing, and maybe that's not a good thing. Then we had the Turkey problem. Maybe what we know about the world, or what we think we know about the world, is not actually the facts. Like the turkey. The turkey thought the turkey knew the farmer. All its life it had lived under the assumptions that the farmer was a nice person. The turkey could not have foreseen what was going to happen. The turkey had induced that the farmer was a nice person, but the induction was wrong. That's an issue. We have an issue that man is too complex. This is often associated with a school of economics known as the Austrians. Nothing really to do with the country Austria, more to do with the fact that they started in Austria in the 1870s, and they went down a slightly different road in economics to everybody else. Well, a radically different road to everybody else. So there was really three types of economics. In very crude terms, there was what's known as neoclassical economics, is what most people study at university and colleges. There's the Austrians, who've got their own particular perspective of the world, and there was Marxian, who also was a variant. But the people who propound the views of the Austrians, this tradition of economics, which is labelled Austrian, nothing to do with the country, as I said, they say, well, man is too complex. There are too many issues associated with being a human. We're emotional. We make snap decisions. We make mistakes. We're not machines. We're not computers. We don't calculate. We don't do things like this. We are humans, and that makes us different. So, is economics a science, given we're dealing with something as complex as man? Yeah, that's an issue worth considering. You can draw, however, comparisons with some natural sciences. We can do that. For example, astronomy. Astronomers can't perform experiments. They can't arrange the planets just for the fun of it and see what happens if they do something else. The planets are the planets. The galaxies are the galaxies. You can't do anything with. They make observations, and based on the observations, they draw conclusions. And that's what economists do. Economists can't perform experiments, but at least they can't perform experiments to a large extent. There is actually, having said that, there is an area of economics called experimental economics, in which they do try to perform experiments to see what is meant by rational behaviour, and do individuals follow rationally certain lines of thought or whatever. And you can perform certain experiments with animals to see if behaviourally, they behave in a certain pattern. But there are examples with the natural sciences. I suppose it all just bubbles down to the fact that we want to know. We're curious. That's what we're like as individuals. We like to know. We want to know what the future is going to give us. We like to know the idea of the future, even though we know we can't project it and we can't have confidence in our estimates of the future. But it's something we think we like to do. So we take limited information and we try to develop ideas of what is likely to happen, even though we know that what we've done is not really that valid. Sometimes in doing this we're using bad information, and we haven't got enough data, we haven't got the right techniques, we don't understand exactly what's happening. We've all the issues that we've discussed here in play as well. So we have, in a sense, bad information. I know that sounds a contradiction, but we have information, we've processed the data. It's not good. It's not reliable, and it could lead to bad decisions. Right, those are a few ideas about economics as a science, and it relates to the Robbins definition. So that concludes this particular video. There will be many more videos on different aspects of the Robbins definition. All the other terms of the definition have to be picked out. In this video we just started with science and human behavior and got to where we are now. So that's it. Thank you for watching.